Hey guys, today we're going to be adding and subtracting radicals, which should be a review from Algebra 1, but we're going to go over it again just to make sure that we're all on the same page. So to get started, you're going to do the do now at the top, A and B. You can pause the video while you do it and then press play again when you're ready to continue. All right, so for A, adding variables, we should know that in order to add them together, they have to be like terms, meaning they have to be the same variable with the same exponent. And we do see here that our two x's are both the same. They have an exponent of 1, which means we can, in fact, add them together. So from the first unit, that means that we are going to add together the coefficients in front. 5 plus 7, we get 12. And then we just bring the x over. The x itself does not change. All we are doing when we are adding or subtracting is seeing how many x's do we have all together. So over here on B, you're going to be doing the same thing. Radicals are treated just like variables. In order to combine, you have to have the same radical. In this case, we have two different radical 3's. So all we are trying to do here is figure out how many radical 3's do we have all together. Well, I have 5 plus 7. We're going to combine the coefficients in front just like we did for question A. So we should get 12 radical 3 as our final answer. The radical does not change, just like the x did not change in the first problem. All we were trying to do was see how many radical 3's do we have all together. So if you want, make yourself a little note down here. Like radicals can be added or subtracted by combining the coefficients and keeping the radical the same. That number inside the radical does not change. All right, so now number 1 here. Notice the directions. They say perform the indicated operations and simplify completely. However, we have a problem here with number 1. Unlike that do now, these radicals are not the same. The way they are written right now, we cannot add them together. Our only option here is to try to simplify first, and then hopefully these radicals do in fact become the same, so this way we can add them. So similar to how we did in class, you are going to add each radical. You're going to simplify each one. So we're going to start with this radical 12. Well, radical 12 is 4 times 3. The 4 is our perfect square. We know it comes out of the radical as a 2. And then the radical 3 stays inside since it is not a perfect square. Well, now we're going to do the same thing with radical 27. Radical 27, we know, is 9 times 3. 9 here is our perfect square. It comes out as a 3, and then the other 3 stays inside. These two are being added together, so we are going to bring down the plus sign. And now by simplifying, we can see that we do in fact have the same radicals here. We have two different radical 3's, similar to question B from the do now. So adding together, we are going to combine those coefficients. 2 plus 3, we get 5. And then we keep the radical 3 the same. That cannot simplify. So your final answer here should be 5 radical 3. All right, number 2, we are going to do the same thing here. Cubed roots are the same as square roots in that they have to be the same radical in order to combine. So now this radical 8 is a perfect cube already. We know that it comes out as a 2. And then the x, because the exponent is smaller than our number inside our radical, the index, it cannot simplify anymore. So this one becomes 2 cubed root x. Well, now we're going to do the same thing with the next one. 27, we should recognize, is a perfect cube. It comes out as a 3. And then same thing with the x over here. It is an x to the first, and our exponent of 1 is less than our index of 3, so that x is going to stay inside. These two are being added together, so don't forget to bring your plus down. And same as the last one, we can now combine together the coefficients in front. 2 plus 3 is 5. And then that cubed root x comes down. We keep it the same. It cannot change. And this is our final answer. All right. So why don't you give number 3 a try here? See if you can do it. Pause the video. And when you're done, you can press play again and check if your answer is correct. All right. So this radical we can break up. 20 is 4 times 5. X to the 4th is already a perfect square, so that doesn't have to break up as two different things. So 4 comes out as a 2. The 5 will stay inside. X to the 4th comes out as an x squared. And don't forget, there was a -8 there that will multiply with this 2. So the things that came out, -8 times 2, we get -16 x squared, since that was a perfect square, it came out. And then the 5 is the only thing that is left inside of this radical. Looking at the next one, the 5 here doesn't have to break up as anything because unfortunately there is no perfect square that goes into 5 that would help us. X to the 4th comes out as the x squared, so all we have to do is copy down here, and again, don't lose that front number. We have -8 x squared radical 5. So now combining, we have like radicals, and we have the same variable with the same exponent. So all we need to do is combine the coefficients from front. We have a -16 and a -8. So we should get a -24 x squared radical 5 as our final answer. Just like the radicals remain unchanged, similar to how we did in the Do Now question A, the x's and their exponents remain unchanged. The only thing we are doing here is combining those leading coefficients. All right, so now that you tried number 3, why don't we try number 4? This one is a cubed root, so be careful with your simplifying. Make sure that you simplify correctly. And then when you are finished, you can check, you can press play again if you paused it, and check your answer to make sure it is. All right, so number 4, cubed roots. We are breaking up this 16. You should be breaking it up as 8 times 2, with 8 being your perfect cube. The variable x to the 9th is already a perfect cube since 9 is divisible by 3, so that one does not have to change. 8 will come out as a 2. X to the 9th comes out as x to the 3rd. Remember, you are doing 9 divided by 3 here. And then, unfortunately, this 2 is going to get left inside. Don't forget to bring down the x that was on the outside and multiply it with this x cubed that just came out. You should get 2x to the 4th on the outside, and then cubed root 2 on the inside. Now, next radical here. We have the cubed root. 54 turns into 27 times 2, with 27 being our perfect cube. X to the 12th is already a perfect cube since 12 is divisible by 3. So this can come out as an X to the 4th. 27 comes out as a 3, and just like the last one, the 2 is left inside. Don't forget to bring down the negative 2 that was in front to multiply with this. You should get negative 6 X to the 4th, and then cubed root 2. So now, just like the last question, you are going to just combine the coefficients in front. 2 minus 6, you should get negative 4. The variable x to the 4th stays the same, and the cubed root of 2 stays there. So that is your final answer. Number 5, why don't we try to pause the video and do some simplifying so that we can try to combine some like terms here. All right, so simplifying this. Both the 90 and the x to the 7th are going to have to simplify here. 90 is 9 times 10, with 9 being the perfect square. A square root, remember, has an index of 2, so your goal is to have your exponent be a multiple of 2. So the closest multiple without going over would make it an x to the 6th. And then we have a single x left over. So this x to the 6th is our perfect square. The 9 is going to come out as a 3. X to the 6th dividing by our index of 2, we get x cubed. Luckily, there is nothing in front of this radical that has to come down. So this one just becomes 3x cubed square root 10x. Now in the middle, breaking up the 10, nothing can happen. But x to the 7th, same thing that we had to do with the last one, is x to the 6th times x. X to the 6th comes out as an x cubed. And don't forget, outside here, we already have a plus 5. So this radical in the middle will become plus 5x cubed radical 10x. Last one now. Breaking up, only the 40 has to break up. It is 4 times 10, with the 4 being a perfect square. That x is left inside. The 4 comes out as a 2. And don't forget the negative x cubed from the front there. So this one becomes negative 2 x cubed with radical 10x left inside. Now, all of these have the same x's with the same exponent, the exact same radical. So again, it is just the coefficients that we are combining. 3 plus 5 minus 2, we should get 6x cubed radical 10x. Okay, last one that we are going to do. Try to simplify all the pieces here for number 6. And when you're done, press play again so we can. All right, so if we see here number 6, radical 50x to the 8th, I broke it up here and it becomes a 5x to the 4th radical 2. Radical 27 breaking up becomes 3 radical 3. Negative x squared radical 18x to the 4th becomes negative 3x to the 4th radical 2. And radical 75 becomes 5 radical 3. Notice not all the radicals are the same. You can only combine like terms. So starting with the x to the 4th radical 2's, we do 5 minus 3, we get 2. And then the radical 3's, we are doing 3 plus 5, we get 8. There is your final answer. Unfortunately, if they're not the same radical, we cannot combine any more than that. We did some adding and subtracting. Tomorrow, we are going to do some more practice with it, so come prepared with any questions you may have.